Yeah. Okay. So, see the material, no, if you see FR4, there is an FR4, and then epsilon is 4.3, and then mu is 1. Mu is always
Okay.
1 because, okay. Then an electrical tan delta is there, right? That is the last
Yes.
tangent, basically. Okay.
Yes.
So
Okay.
here it is 0.025. Similarly, you will have for all the material, no, you will have this similar kind of thing. And thermal
Okay.
conductivity. See, these three parameters are, two parameters are very important. One is dielectric epsilon, and then dielectric electrical tangent, means tan
Okay.
delta.
Okay, sir. And
Okay.
thermal
So,
conductivity.
yeah, thermal conductivity, it's fine because, unless you are doing any thermal analysis, it's okay. If you're not doing any thermal analysis, you can just simply ignore that. Okay. If you want to really do the thermal analysis, how it works in the 27 degree, 20 ambient temperature and high temperature like that, that time you need to discuss about that. Otherwise, two parameters are sufficient. One is epsilon and tan delta, unless you have a, mu more than one. Okay. Actually.
So, sir, one thing I know, I think mu will be 1 and epsilon will be 3. 3.
Okay.
Uh, Sir, in paper they already given.
Then you can follow the same thing, right?
Yes, sir. Uh, that the silicon dioxide and polysilicon, the dielectric constant of polysilicon silicon dioxide is 3 and 3.9.
Okay. Okay.
But they did not mention about loss tangent actually.
Okay.
So what should, in this case, what should I consider?
Which one you are telling?
Uh, the uh, uh, dielectric
Okay.
constant. Yes,
3.9, 3.3. Okay.
yes,
The
sir.
three layers. Okay. So then you can just, search in the net that silicon dioxide. Okay. Then
Okay.
you may get that if you are getting the same numbers, like, three still dielectric constant, then the corresponding dielectric loss tangent, you can just collect it. No problem.
Okay. Just the thing is, yes, should search in for a dielectric constant. Okay.
Yes, yes. Then if you get that, if you have material, silicon dioxide material, which is with this one, the corresponding last tangent, you can just feed it. That's it. Okay.
So
See, last tangent, no, will define only the gain calculation like that. Okay. Uh,
hello.
yeah, yeah, no problem. So it will be no problem. Yeah.
Yeah. And second thing is, sir, for graphite, they also, I was thinking like graphene is already defined here, but
Okay.
I think they are not. The graphene is also not available, so I think I should also add graphene because they are only given graphite.
Graphite. Okay, you can add graphene. First, what you can do is, um, see, the thing is, what you can do is, you can just first design the same thing, whatever they have done. If you can reproduce the results, then you can just change this graphene like that, so that it will be easy for you to validate that, and then you can just enhance the feature basically.
Okay, okay.
Yeah.
So, sir, but the property, I think I need properties of these material. I think
Which one?
either uh, uh, can I use another material in this replace? Can I
See,
replace?
the thing is, what I'm telling is, see, even you can just you can define the material with only delta constant, and then run the simulation, and then if you get that results, same results, then it's fine. Okay,
Okay,
then it's
okay.
fine. So then you can just on top of that, you can change material as your wish. Okay, whichever is available material, easily
Okay.
available material, then you can try that. Okay, so that you can see that, okay, yeah, I'm getting the results, which means my simulation model is correct, and then
Okay.
I'm just on top of that, I'm just changing the material, and then introducing the graphene to enhance the means underarm performance
So should I add with this dielectric constant only?
alone. Yeah, yeah, you can
Alone?
no problem. See, last time, will not have much deviations. unless,
Okay.
in the matching and all, much deviation will not be there. Only the attenuation part will have something. Okay. So dielectric constant is the main parameter basically.
So, conductivity is also required, sir. Either can
Conductivity
I?
is okay. It's okay. It's okay. No problem. So because conductivity you don't know, right? And if
Yes,
you
sir.
know dielectric, then yeah, it's okay. No problem.
Where should I epsilon?
Epsilon is, here. Yes, yes, exactly. You apply and then, name it as, the value.
Polysilicon.
Yes, 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 exactly. Polysilicon, what is the value? Yeah, yeah, three,
Three,
three.
three.
Yeah, same thing you
First
can
is
use.
polysilicon. Sir, I was thinking like I can go to the NCCA console where I
Okay.
can just find some values like their
Yeah, that also
predefined
fine. Yeah, that
material.
also fine. Yeah, that also fine. Means if it
Yeah.
is matching there, then you can just get it there. No problem.
Mm.
Yeah, definitely.
Should I add now? Is there anything I require?
No, no issues. See, if unless you find that, it's okay. Otherwise, no problem. Yeah. It's okay, no problem. You can just, use that material alone.
Even I can't added this name actually. This is coming only material one. I don't know myself.
It's okay. So see, if you give add, yeah, add, just add. Yeah, material one. Okay.
So is it okay? Because polysilicon is which is thickness is 50 nanometer.
Yeah, 15 nanometer, right? Then you have to
50,
use
50.
50, right?
Yes, sir.
50, right? 50,
Yes,
right?
sir. Yes.
50 nanometer, then it will be 50,000, right? Actually, micrometer.
Nanometer, actually,
Sorry, point
micrometer.
zero five, point zero five. Sorry.
Yes,
Point zero
yes,
five, correct. Yeah,
0.5.
yeah.
What is
Yes,
that
just above
about?
that. Exactly. Correct. Yeah. Similarly, you can do that for other as well.
But can I also exclude that part? I can't.
Yeah, you can extrude. But I think, can you show that structure, please? Yeah. Is it just above that? Um,
Poly patches, so
Patches. Yeah,
just
just
above
above.
top patches.
Okay. Then you can extrude here also. No problem. Yeah. I can do. Transform. You can click on that by space. Okay. Oh, not transform. Sorry. No. Cancel this. Yes. Press yes. No. Press yes. Uh, can you show the front view? Yeah,
Is it
yeah, this
visible,
one.
sir?
Yeah, yeah, it's visible. No, no, no. You click on that. Just a front view surface. Yeah, click on that. Double click on that. Yes. Now you can extrude. Yeah.
Mhm.
You can name it as, silicon dioxide or something like that. Plus, no, no, height you have to give only the value. That's all. You don't have to give these things. Because, it
Sir,
will be placed just above that. Yeah.
like previously the height above that. Uh,
No, 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 no. You go to the paper. I will tell you. Here, what is the mention? 50 nanometer, right?
yes, sir.
Again, 50 nanometer. Then you can use that 50, um,
Okay, sorry, I got it.
0.05. Yeah.
Okay.
Yes.
Should I first?
Yeah,
I
yeah. You can
think.
add new material. New material. Yeah.
Okay, sir. But sir,
Silicon.
actually, they are just giving silicon only.
Okay, but that is having epsilon of 9.2. Usually it will be like that. Okay, then you
Yes.
can add new material, no problem. Yeah. You can mention the name, material name as silicon like that on the top.
2.9.
On the top, material 2 is there, right? You can just mention the name as silicon,
Okay.
SiO2 like that.
Is it okay, sir?
Yes.
Now?
Yeah, 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 it's okay, no problem. Yeah,
Okay.
okay.
Sir, again, I can extrude.
Yeah, 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 definitely. Can. Yeah, no, no, yeah, okay. Polysilicon, not polysilicon, SiO2. Just above the SiO2. Because, yeah.
Uh, that is a height is 3.09 actually.
Yeah, can you see?
3.06, sorry.
3.06, right? Then 0.0306, like that you out, right?
0.0306.
Yes. No, 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 no. 0.00306.
Okay.
Correct, because uh, it's a 3 only, right? 10
Yes,
power
sir.
minus 3. Yeah. 0.0303. Yeah, yes. 303.
0.00306.
6 or, yeah.
And sir, material already given, that is
No, no, not this one. Load material.
graphite.
Is it okay?
Uh,
No, 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 no. Graphite is different, right?
Graphene and graphite is different, and they're in paper they didn't give any information about graphene actually.
Oh,
So yes, sir. Uh, that's why I choose CST, because I thought I already seen some videos there. They are saying ki we can use CST for graphene. So
oh,
the
it's okay. Hmm.
like in paper, they're not giving any information about graphene. The main problem is I think I should again uh, have to learn some paper. I have to search some paper for graphene actually, I think.
Okay.
Because I think these value are not given to any paper, because
Yeah, because graphene also, we don't know how the slicing is done, and based on that material will be changing.
yes.
Uh, yeah. Okay. As of now, you can use this one. but you have to necessarily validate this graphene when some other papers are somewhere, they might have given somewhere. Okay, you can use
Okay.
that.
Okay.
Yeah.
So should I use this graphite right now?
But graphite is different, but okay, for timing you can use this one. But graphene, no, you have to find out. Or else in net also, in the net also you will be getting right.
Sir, actually, I searched a lot, but I did not get any as much information. I was not sure about graphene
It is
because I
showing
think
us, oh, bilayer surface 6 plus 1 minus 2. Whether it's coming basically. Okay, so graphene material. Uh, uh,
actually console they are using graphene, but they already have lot of graphene.
okay.
But I think I should check graphene first in console. Then I just
Yeah.
load as a new
Yeah. Only
material.
the material. That's all. Right.
Okay.
So yeah.
So
Anyway, now
I
you
will,
can design.
yes, sir. I will do that thing after. Then what I will do after that, sir?
Yeah. Okay. No problem. You can just add this one. Okay. Just go to simulation.
Wait, sir. Should I add graphene right now for?
Yeah. For now, you can just add graphite and leave it. Okay.
Okay, sir.
Then you can add that material. Okay. Later on. Okay. Load. Okay. Click OK.
Okay.
Yeah. Now go to boundary conditions, simulation and boundary condition, boundaries, boundaries.
So first frequency, I think.
Yeah. You can just
Okay,
set it.
already
Frequency is already
given.
set, right? Okay. Boundary. You can just put boundary. Yeah. Here, no, flocket boundaries. Go to flocket boundaries.
So first, I think Z minimum is not required.
Not required. You see, if it is there also, no problem. Don't worry.
Okay,
Okay.
okay.
And flocket boundaries here, actually
Yes, sir.
distance reference plane. No, you can just put 9,300 divided by.
Minus
No, yeah. Minus 9,300 by divided by 2. Correct.
and number of
Then
flocket mode.
details.
What is
Yeah,
the
actually this one, no, see, it's a two modes means it will excite it. For example, you will get a result in both the vertical potential and horizontal potential. That is the one. One of the video and all I might have explained this one, how this works. Okay. Can you go to details, please? Details, please. Details. Here, no, you have to put the frequency of, for example, 15 gig. 15. Yeah. Then the modes parameter will be updated. Can you click update? So can you see here on the bottom, you can see maximum order X1, maximum
yes,
order one Y1,
what
Y
is this,
dash.
sir?
This is means see your vertical potential and horizontal potential. On the top also you can see mode number 1, 2. You will see that TE mode and TM mode.
Okay,
TE
sir.
mode is nothing but your vertical potential. TM mode is means see it's a dual polarized exactly. So two plane waves will be sent in two different potentials. That is the meaning. Okay. This is for a Zmin. Okay. Apply this one. Okay, this one. Can you click OK? Yeah. Again, anything else? Okay, close this. Okay. Can you go to port? Port. Can you go to ports on the bottom? Yeah. Here, Zmax. Can you go to Zmax? Double click on that. The red line is on the just on the because the reference line is 0. That's why it is showing like that. Can you go to Zmax? Double click on that. Yeah, here you put minus 9,300 divided by 2.
So why they here they're showing 0? Because I already put the value na
No,
in
no,
the
no, no, no. Zmin you put for Zmin. That's why I asked you to
okay.
divided by 2. Okay, go to details. Details. You can put here 15. Yeah, it's okay. Update. Okay, click OK. Click OK.
Uh,
Yeah, click OK. Can you see here? Yeah, can you click on the port, please? Again, you can go and click on the port, please. Yeah. No, click on the Zmax, please. Yeah. Can you see here where it is going? Oh, okay. No. Okay, go to background, go to background. Because it is taking center frequency as different. So lower z distance, no, upper z distance, you put 9300 divided by 2.
Sir, in lower Z direction.
Yeah, no, lower z on the bottom.
Lower Z, okay.
Yeah. 9300 divided by 2. Upper
Upper.
z direction is 9300 divided by 2. Can you preview it?
Where can
Ah,
I preview?
click somewhere else. ZY like that. Okay, click OK. It's okay. Click OK.
How to
Okay, positive only. Sorry. It should be positive only. Yeah. It will automatically taking care. Plus you remove the minus only. Click OK. Yes. Can you see here? No. Because it is taking 30 gig as the center frequency. 1 to 60, right? So it will
yes,
be
sir.
taking a 30.5 usually default.
Okay.
Now we can put like this. Okay, cancel this. Okay, click OK. Click OK. Yes. That's it. Okay. So now it's fine now. Now we can
So,
start simulating this one. No problem. Okay.
okay. So
We can
where
just,
is Z max? Is here.
yeah.
So why are showing this cross like
See, which means, see, what I'm doing is, see, you are exciting the plane waves or, the waves from the Z mix that port position. Okay.
okay, sir.
The wave will go propagate and then hit on the surface, then it reflects back, right? We
Yes,
want to observe just above that surface, right? That is the reference plane. We are keeping that reference plane there. We want to observe the reflection at the just above the surface. That's why we are doing that. Okay.
okay. Sir,
Yeah.
why we always choose what if we choose lambda is lambda by less than lambda by 4, yeah, greater than lambda by 4, like for this waveguide length from top of the
Basically, if you construct this, see, as an unit cell element, no, you can have a lambda by 4 also. It's fine. No problem.
okay, okay,
Okay. The only thing is, only when you cascade that many cells, no, you will see a lot of different behavior. So in general, it is come from RI theory. But see, there are number of unit cells that have a lambda by 4 also. Okay. It depends. So you can just design, you by default we used to go for the lambda by 2. But there is no harm. In zero point 0.7 lambda also you can go, zero point 0.5 lambda also you can go, 0.25 lambda also you can go. But the depends upon the use case, the effect will be there. Okay, for example, if you are designing a unit cell element, then you will see the grating lobes. Zero point 0.7 lambda means maybe beyond 0.7 lambda. Then if you go there and those things, right? If you go beyond below the 0.5 lambda, then you will see the gain differences. So that's why it's a difference upon the use case to use case difference. Okay.
okay, okay.
Yeah.
Sir, is there any concept behind like if we are choosing greater than lambda, the impedance matching should be required, and if we are choosing this reference point to port length distance is more than lambda by 4, yeah, minimum, yeah, more than lambda by 4, what will be effect
See,
on result?
I think in one of the videos I mentioned clearly that see why we are doing this kind of exercise. No, see we are exciting the plane waves. Okay, it is going there. Now it is traveling lambda by 4 distance means 90 degree it is getting traveled. Okay,
Okay,
okay, then gets reflected or
yeah,
transmitted. Then reflected by the degree of, for example, 180 degree. Okay,
okay,
then
okay,
again it is traveling back to the 90 degree so that you will get that. Means no, for net phase is different, zero, right? So that's
okay,
why the lambda by 4 came into picture, basically. Yeah.
okay, sir. Now I will simulate this.
Yeah. Or in other words, usually we use quarter wave transformer, right? Usually in the
Yes.
for the patch, right? So mac on the lambda by 4 distance, you will get the max, right? You will see the max, correct? From the signal to lambda by 4. In sine wave, if you take quarter wave, then you will see the maximum excitation, right? Maybe that may be the reason also. So there are multiple reasons are there for this lambda by 4, lambda by 2, all that stuff. Yeah.
Sir, like if I want to uh, add new material and something like that. So
Yeah.
what should be procedure so that I can find that I'm going to in right path actually. I read lot of paper for graphene, but I was not able to understand properly what is going on inside graphene because lot of paper have different
See, the
ideas.
thing is,
Yes.
the thing is, see, it is like this. So if you talk in terms of this graphene, means any material, right? Here, what they have done, they have used some patches. Just above that, we have several layers, right? Layers, okay. So, so several layers, right? Um, so, several layers, correct. So this is to enhance the mesh cannot be generated. Maybe memory issue. What is the issue?
I don't know, sir.
Just about that code, just about that.
The length ratio between shortest and longest model edges is 1.3. Short model
Okay.
edges
You have to
20.
reduce the meshes, basically.
For what should I global properties? Yeah.
Uh, yeah. Okay, okay. Just reduce the mesh by 5 or something like that. You can try because I'm having urgent call now. Okay. I'm just,
Okay, sir.
go there. Yeah,
So
thank you.
edges will be 5. Model 5.
Yeah, you can put, yeah.
Okay.
Or you
Thank you
can
so
increase
much.
the answers. Increase and try. Okay. Don't
Okay,
worry.
okay. Thank you so much, sir.
Thank you.
Okay. Bye, sir.